morning everyone. Myself Manjuladevi, Department of Computer Application. Today I present my topic in Dekker and Peterson algorithm. Let's go on the topic. In a Dekker's and Peterson algorithm was a two classical mutual exclusion problem. In a Dekker's algorithm was a older one, and the and then Peterson algorithm was the new algorithm. Both are used for the processing in the OS. And process is nothing but it is a unit of work in the system. In a Peterson algorithm, it's simple or more conclusive. Include the Dekkers by using the compound condition to the process entry, and both algorithm using the operating system in the current programming. And the Dekker's algorithm was first correct solution to critical problem for the two process. It's significant history of the system because it avoids to drawback of the native alternation. It used to share a memory. It ensure mutual exclusion and progress and bounded waiting. And these are the process generally represented as a Dekker's algorithm. First we coding is first condition is a do loop, and we go to the entry section, and next move on the critical section, and finally move to the exit section, and the remainder section where the while condition is true, otherwise the remainder section will not be executed. The solution to critical selection problem must be ensure the three conditions. One is mutual exclusion, and another one is a progress, and third one is a bounded waiting. So first we come across as a evolution of the Dekker algorithm. It have the 5 version of the Dekker algorithm: first, second, third, fourth, fifth. So the first version of Dekker algorithm, the idea was to share the variable, turn it design whole turn on it, and then execution process only one in the turn matches in the ID, and the problem in one process entering, the other may be wait forward the progress guarantee. And then second version of the Dekker solution is the idea was the each process to the boolean flag to the show intent, and the execution to the set as in a flag. The other process checks to the session of the entering operating system. And the problem is prevent after setting a flag, both may enter and exit execution avoided. And next we come across as a third version of the Dekker solution. In the third version of the Dekker solution, the idea is used to process set in a flag before entering waiting loop, and the next one is a execution. Both cannot enter simultaneously, both mutual exclusion and the process. So the both cannot enter simultaneously, enter the exclusion. And the problem is to set a flag at the same time, both are wait for the deadlock box. These are the third version of the Dekker solution. And then fourth version of Dekker solution is here. The idea is used to conflict reset the flag, and then exclusion to avoid the deadlock by letting one back off. And then problem is used to one process may repeatedly lose, identify the postponed problem. The postponed means the process which process are done before the problem. And the Dekker algorithm, a final completed solution. This is also called as a fifth solution. This solution is used for the current version. In the idea is used to combine both flag and turn priority based scheduling. It's like a first come first serve, stack or queue. These are the under the Dekker's fifth algorithm, and then execution used to enter the design who after exit and turn is to past. The solution are mutual exclusion, progress, and the bounded waiting. So the summary of the version is versions, so mechanism and the problem. So first version is used to turn variable only, so it used to for a strict alternations, so no process in your own process exits as permanently. So next one is a flag is the after entry loop, it used for the mutual exclusion attempt, both may enter the violation. And third one is a black before entry of the flag. So it ensure the mutual exclusion, and also the deadlock is possible in the section. And fourth one is a flag and random back off. It avoid the deadlock and starvation identity to the postponed. And fifth one is a final Dekker's algorithm. The final Dekker algorithm is mechanism used for both flag and turn variable. It used to correct the solution in a 3 requirement. It ensure all the 3 requirement, it like a mutual exclusion and the progress and then algorithm. So these are the summary version of the Dekker's algorithm. So next we summarize the Peterson algorithm. So the Peterson algorithm is developed by the Peterson in 1981. So let's we talk about the Peterson algorithm. The Peterson algorithm is used for the classic software solution in a critical problem of the operating system. So like in an operating system, a problem is occurred, then we used to the Peterson algorithm for solve the problem. The algorithm is used to shared variable, flag of I and turn. A flag of I show the process enter to the critical section, and turn is used to indicate both process and access a critical section at the same time. An example of the use cases, the Peterson algorithm theoretically in access a shared printer, reading and writing to shared file, committing a shared resource. For accessing a shared printer, it ensures to access the printer whatever time the process are occurred, then we use the printer. And reading and write to shared file, the process read and write in same file, it prevent the access to issues. And committing for the shared resource, we can write or print out the document, then we final step is to share the resource to everyone, because they everyone access and use the particular resource or particular topic in OS. And it is the overall conclusion, the Dekker's algorithm and the Peterson algorithm. The Dekker's algorithm, it was developed by the T. Dekker in 1965, and the Peterson algorithm, it was developed by the Gray Peterson in 1981. The number of process in Dekker algorithm designed for the 2 process only, but the Peterson algorithm is also same as a design for 2 process. And a mechanism in Dekker's algorithm we use as a flag for the run on turn and complex check of the problem, and the Peterson algorithm use flags, turn, simpler and checks. And then fairness of the Dekker's algorithm, it ensure fairness and higher overheated, and the Peterson algorithm, it used for the problem to solve the problem of the efficiency. And then complexity in the Dekker's algorithm is more complex and highly overheated, and the Peterson algorithm is a simpler and more efficient. Weighting process in a Dekker's algorithm, it weight is a more indicating checks, but the Peterson algorithm it is more efficient, and then efficiency of the Dekker's algorithm to less efficient due to complex check, and the Peterson algorithm it used to more efficient to the complex check, and then mutual exclusion of the Dekker algorithm and the mutual exclusion are happen in the Dekker algorithm. So the complementary is S, and the Peterson algorithm it the complementary is S. So the Dekker and Peterson algorithm used for the both mutual exclusion process and then algorithm find the solutions. So these are 2 algorithm mostly used for the OS because OS in your main focusing on the process. A process is a program execution, it is unit of work in the system. So a process work done well successfully, then we use the Dekker's and Peterson algorithm. Both algorithm give various advantages and disadvantages, but based on the situation, whatever the problem we have, and based on situation, these all algorithms are used. I hope you all understand the topic. So let's move on to the next topic. Thank you.